Well, good morning, everyone. As Janet said, my name is Roberto Piña. This is my first ARC conference, so hope I don't seem too nervous up here. But today we'll be describing, or at least I'll be describing, how we at Dupont, increased our compliance to external standards at reduced cost by digitalization. And so, just a little about Dupont. I'm sure most of you already know lots about Dupont, but Dupont's a pretty large specialty material organization, and we're in many markets around the globe, in electronics, transportation, construction, and protection, just to name a few. But you can see the list of products. These are just a few of the products that we offer at Dupont, and I personally am involved or the process control leader for the the Nomex and Kevlar businesses, the Airman's business. So today, what we're looking at, or what we're seeing, and I'm sure it's not just us at Dupont, we're seeing that external standards are becoming much more restrictive, in terms of what the requirements are, and making compliance to those standards just more resource intensive. For our resources at Dupont, we're asked to collect more data. We're asked to monitor more equipment with the equipment that's on, especially in process controls. Everything's starting to get connected. You're starting to get more smart equipment out there, Internet of Things, and the breadth of items that we're being asked to monitor is just getting more and more. And along with that, you have to always adhere to these standards. So how do you do that? What we as a industry need to do is take advantage of digitalization and automation techniques so that we can make our workers much more efficient. And, I want to take you on a little journey here, because this is a journey. It's not something that we did overnight. For Dupont, our strategies, we created a process safety and automation organization. Was not a independent organization. It really was a collaboration of workers and users, and this was in addition to everyone's job, But the strategy we developed is kind of laid out right here pictorially and in words. But first and foremost, what you have to do is create your standards. Your standards are the basis of what you're doing in your organizations. You have to align and update your standards so that they comply with all the external standards. And this is the what, if you will. That's what needs to be followed, and if you don't know what you're trying to adhere to, you can't necessarily choose something to get you there. And second, after you've laid down that basis, is that you need to choose, the tools and the work processes, the best practices, create those to get you to where you're going. So that is the how you're going to get there to your destination. And again, I can't stress enough that standards down at the bottom there is the basis for everything that you're doing. Now, what you're going to do as part of that is just make sure that you're going to standardize your work to be more efficient, and part of that is the digitalization process, so that you can choose the tools and the data that you need to be made available to your resources to allow them to execute their work efficiently. Then comes the training. This is the who. All of the resources that are included in your work process need to be trained. And not only on just the tools out there, but also on the processes themselves. Because you can have the best processes, the best tools out there, but if your resources are not trained, if they don't know how to use those processes, nothing is really going to change. And finally, you want to periodically review the performance of your entire program there, not just processes, not just metrics on how you're complying with the standards as they are. You need to review the entire program, your training, your best practices, your tools, as well as the standards, because external standards and external incidents and other things may influence you and make you say, hey, we need to update this, or this doesn't quite comply, so we need to update those. So you always want to make sure that as a metric, as a review process, you go back and check the performance of holistically the entire program. So along with that, we also defined, as we're going through this digitalization process, we had to define this for our leadership. And for us, we wanted to automate aspects of existing tasks for our resources out there, to shift those resources to new tasks. And we wanted to make sure the use of data from those automated tasks, we wanted to use that data to drive new improvements. And that was how we were able to justify our digitization process. Because not only are we taking this worker over here who has just got his arms up, he's got so much work to do. He's poorly motivated, doesn't have, as high of accountability for these, lower priority processes, and he's got other priorities to do. So what do? We automate the task, we validate, and we complete the data set so that we have everything that we need, and we use standard tools and standard work processes to do it. So not only are we doing this at one site, we're trying to create processes and create tools that we can use everywhere. So along with that, we, of course, had to develop our business cases. So of the tool that we were looking to utilize, we identified some key areas and split it out between, some hard savings. Of course, everybody loves the hard savings out there, and then it also had some soft savings there. But what we identified, really the big ones are the first two. What we utilized for our independent protection layer, test optimization, as well as the controller performance monitoring. That's where we saw that we can get some really big savings in our organizations. So with the IPL test and demand tracking tool, we're looking to reduce downtime, maintenance labor by automating our test documentation. So we're expecting to streamline the incident investigation process, providing additional data with event notifications to assist our operations personnel to determine if the event was a true event or not. So those are two big things. So one, we're taking because we're getting in additional data, because we're automated some of our tests here, we're able to say with that additional data that our safety instrumented functions are performing exactly where we expect them to be, and they're not degrading. And because of that, we can use that diagnostic data to push out our turnarounds, so our shutdowns, and that, especially in a sold out business, makes money. And then on the flip side, we're also taking those automated processes, again, additional data that we're bringing in, automating our testing results so that we don't have to utilize maintenance labor and utilize operations labor as well as technical labor to document and run the test. We're able to automate the test cycles in the control systems and automate the data coming back in to provide those testing reports. The second big one is that controller performance monitoring right next to it in the blue box. So with that, we're, as we know, not everyone is, constantly monitoring your control loops out there and looking for, bad actors. Really, the only time bad actors comes in is when it creates an issue out on the shop floor, creating quality issues or creating instability in the process. But you could have a number of control loops out there that are poorly performing and really, in the long term, just eating your lunch in terms of energy costs and valve maintenance and additional instabilities that your other control loops are accounting for, but it's still costing you additional money. So that's those are the two big ones. The The third one that you can get some hard savings for is a boundary analysis program that you could use for standard operating conditions, monitoring your standard operating conditions when you are when you have an excursion away from your aim, and so you may not be producing off-spec product, but you're using more energy or you're using more raw materials than you should. And so if you can alert operations staff to those excursions in a timely manner, then that would allow you to run much more efficiently. At many of the sites where we implemented the software here, we already had some of those tools built in for our standard operating condition compliance. But so in this case, we had it on there that some of our facilities, we could definitely use it. Not all of our facilities are monitoring their boundaries, and some of our facilities are. But we did note it as a justification for using this tool here. And I won't go into many of the other soft savings here, but the tool that we decided to use was by far, allowed us to really gather a lot of data. And it didn't matter the amount of data that we pulled in. It was all the same amount of data. It just used it in different ways. But along with choosing the tool, you really need to consider everything else around your existing operations. So there were a lot of boundaries that we had to keep track of. So, in this case, we call them guardrails. We already had processes and work practices around auditing, incident investigations, PHA analysis, the learning systems and the maintenance management systems. So we could not change these practices. These are already work practices that are out there, and they're not necessarily the same work practices at all of the sites. So we did not want to, when we were choosing our tools and creating our best practices, creating our new work processes that we want to build into, we had to make sure to stay within the bounds of the existing processes out there. And that's something that you need to make sure to consider when you're putting in your new tools. You can't just throw something out there and expect it to work. But that's also something you absolutely need to evaluate when choosing new tools, how you're going to interact with what's existing. So it was quite an exercise, to be honest. It was something here. And just to give you kind of what we were dealing with, this is a typical data flow that we were looking at for our safety instrumented systems. So you get a SIF, you start with your process hazard analysis. That gives you and defines your functions, defines the initiating events. You then feed that into your safety requirement specification, into your design process. You start to flush that out, and you get your devices and your final elements. And then from there, that's where you start to implementation. How are you going to pull that implementation all together? You start getting into your monitoring phase, your monitoring tools, and that's where the software that we put in really helped us with demand tracking, performance tracking, and automated testing. It also helped flush out the evaluation process there with the man data and the bypass data. But again, once you go into this, it's all an iterative process. We were able to come through, and with that data integration and being able to integrate all of that data together, it changed how we use that data. We now had data that we didn't expect to have. Part of that was that the tool not only looked at the initiation of the SIF, it also looked at the final elements, and we were able to see when those final elements get to a safe state, which is not something we had before. And once we were able to get that additional data, we said, hey, well, now we can not only see when and track our demands when they occurred, but we can also see, are they functioning as expected? Are they functioning per the design? And so it also led us to see that we did not properly instrument all of our final elements. So we're like, wow, used to be that it was a nice to have. Hey, it would be good to know if this valve closed when it's supposed to. Now that we have a system to provide the evaluation and the performance analysis of all of our SIF elements, now it becomes data that we really need to have, because now we can use that data in an automated way to track fully the performance of our SIFs over time, not just to say, yes, did it function, but is it still functioning correctly and not degrading? Now, this is a little bit of an eye chart. It's a bit complicated, but this is our typical process, if you will, for an event, a demand that happens. So you've got up at the top the activity, if you will, for starting from operations, event detection, event notification, event response, into your investigation phase, and then your performance monitoring phase. And then on the side here are the different applications that we use and what we touch when you think about when you're trying to track all of that data. So you start with your control system up at the top, and your historians, the alarm and event historians, your process data historians, the event demand tracking software, and the emails, the notification systems, and on down the list, getting into your management systems and your learning systems. And you don't realize until you start to map out the process of how complicated trying to get data together is. And this is what digitization is. So people think digitization is just taking the data and put it into a server somewhere. And that's not exactly it. Digitization is making all of that data work together. So I've got all that data, and what we're trying to do is we are trying to make sure and try to automate as much as we can. But right now, not everything's automated. But we have been able to automate up at the top. An event happens, we can capture that event, we can report and notify that event, and along with that notification, we've added supplemental data from our historians to help with the reporting process. So now, not only do our operations personnel get information that says, hey, you've had a demand trip, along with that is supplemental data that says, oh, along with this here's the fuel components, here are the pump components and other things, trends from 5 or 10 minutes before to 5 or 10 minutes after that let them know that everything went to a safe state. And you can see when that demand happens, oh wait, we were already at a safe state. We were shut down. We just ended up not following the process correctly. And so we tripped an interlock by mistake. Well, it's not a demand trip. It was already in a safe state. Or we can see, yes, everything was running fine and something started to trend out of control and shut our system down. And now you also have that additional data can say, oh yes, everything did follow what it was supposed to. All of the safety elements functioned as they were supposed to using trend data, and then we can see everything kind of trending down to a safe state. So all of that data helps our operations personnel to really accelerate the investigation process. So while it's not automated coming from that notification into the acceleration, into the incident investigation process, all of that data is provided to those operations personnel. And then it makes our incident investigation go much, much faster. It fairly automates because we can now take all of this information, push it in, and we are standardizing the amount of information that we need to have or the type of information we're asking for in our incident investigations. And so that pushes out into our incident reporting. It allows us, when we are reviewing it on our cyclic PHAs, that we can have all of the same type of data so we can verify all of that information. And if we did have any demand trips, that we can say, yes, this is why we had the demand trip. Everything worked as it was supposed to. And this is what we did to try to prevent that in the future. And then at the end, again, we're trying to, again, with all of that data, following up with our performance analysis, looking at the metrics, how many trip demands did we have, how many did everything trip in the appropriate amount of time, following the design time, following the safety time, and then analyzing all of that. Did we have more trips than we were supposed to, or more trips over time? Are we going in the wrong direction, or are we improving? But what did all this buy us? You can't just go in and decide to do all this and not expect to get some. So for Tyvek, we were able to have a reduction of one turnaround out of every 3 years. We normally shut down every 12 months in Tyvek, and we were able to extend that out to 18 months just with doing our automated testing. Again, with that, we're looking to add additional instrumentation so that we can further get the diagnostics, because like I said before, we did not have all of that feedback from our final elements. Once we get that feedback from our final elements, again, we'll be able to extend that. So we are looking to try to extend out to 3 years, maybe even 5 years. And for a business like Tyvek that is sold out, that's just a lot of money. So our turnarounds are typically 20 to 30 days on average when you go through a turnaround, and being able to get that additional 20 to 30 days of production is something that all of our leadership is really foaming at the mouth at. So definitely. And then for our controller performance monitoring, not as big, as what we did in Tyvek, but definitely was able to identify quite a few loops. One in particular was a loop that was causing some byproducts and we had to recycle around and blend out, and it was causing us to use a lot more raw materials than we needed to, and so we were able to save thousands of dollars a month on that and move forward with that. So definitely some improvements there. But I will say, leave you with one key learning here is that tools are just that. They're tools. So they're only part of the solution. If you don't build that efficient work processes around that and train your resources on those, then nothing changes. They just, tools are very easy to just implement and forget. You need to make sure to build those work processes, train on those work processes, and follow those work processes. That's all.